our second installment of our Distinguished Lecturer Series for Fall 2025, the Homecoming Edition. So we're excited to have with us today Mr. Matthew Gill, one of our alumni for Homecoming. He's going to be talking on Make It, Break It, Just Don't Fake It, for problem solving for passion and profit. So Matt has been a problem solver and systems admin and scripter for about 20 years. From working in the U.S. Marine Corps, education, radio, and currently in the private sector, the majority of his experience has been focused on solving problems in a variety of interesting and creative ways. And so we are excited to hear what you have to say today. And I think after this, he's headed over to Capstone to watch that. So the fun won't stop when this ends. The party's going to keep going. So follow him on over to Capstone. But without further ado, Matt, take it. Thanks.
Put this up real quick. Hi, so thanks, Dr. Hatchie. Yeah, so my name is Matt, and I work for Blue Cross Blue Shield of Louisiana. I'm a problem solver. I'm technically a site reliability engineer, but none of you know what that is, except maybe you, maybe you. I don't even know what it is sometimes. So we're going to go through the slides. Hey, Seth, we're going to go through the slides. This is going to be really informal. I think I have a slide on this in a minute. Oh yeah, it's right here, the safe harbor statement. These are great because it allows me to say things like anything I can, or I say up here, it almost was a legal thing. Anything I say up here is my own sort of observation, right? My own journey, things I've learned through that, and it might not apply. You shouldn't ever hear something that someone says and you just think I can copy and paste that and do that. That's what I found, at least. You have to adapt it to your life, to how you work, to how you live, to what you want and what you want out of life. So I'm wrong frequently. Ask my wife. This is just me saying that, like, I'm going to do my best to convey this to the best of my ability, but presentations are weird. I'm under a time limit. I talk a lot, so I might not get to some things. I might forget to say some things. I don't have speaker notes. You're getting this sort of in its most raw form. Full disclosure, I had planned a completely different presentation, and it kind of sounded preachy whenever I was writing it. And I didn't want to do that. I didn't want it to be preachy. I wanted to say, oh yeah, you got to be passionate about everything you do. Okay, fine. That's true. You do. You should. Some people won't. That's fine too. But just understand some of that leaks in to, or some of that will have leaked in to this presentation. But a lot of it is going to be less technical and more, I would say, focused on what I do in the real world. Right? I still write code. I still do all the technical stuff. But it's not going to be focused on code because it's very likely that everyone in here is better at writing code than I am. Right? That doesn't make me less good at problem solving. It just makes it focused on solving those problems different ways. And then note on the presentation, there's not a lot of color in this presentation. There is some, just because different shades of gray probably weren't going to work on here. But this is a very minimal presentation. I used to be big into super produced transitions and not sounds or anything like that, but everything had a point. I remember whenever I was TAing for 285 and 485 or 411 and 383, that I would give a how to present presentation. And it was all of these, guidelines and rules to follow while you're presenting. One of them was make an engaging presentation. Over time, and giving hundreds of presentations, I've refined that to be, you need to be engaging. The presentation and you as part of the presentation need to be engaging. So I decided for this one, it's not going to have a ton of images. It's going to be like an O'Reilly textbook or an O'Reilly reference book. It's going to have like a picture of a bird or an eye, or in this case, a harbor, safe harbor statement. See, I'm tying it together. It's not going to have a lot of stuff like that. And some of you probably don't want to stay for this whole presentation. I understand you got stuff to do. Gnarly barley is a thing that's happening, right? So I'm going to give you the TLDR, secrets to my success, right now. This is before the whole presentation opens up. I'm reasonably intelligent. I am not of average intelligence. I'm of slightly above average intelligence. That's not being proud. That's just being realistic. I've seen enough people. I've worked in the industry long enough to know that I am not as smart as I thought I was, but I'm smarter than sometimes I think I am. And I'm above that average bar. You don't have to be a genius to make it in this industry. But you do have to have a couple other things going for you that I've seen that make it so that I really want to work with you. You really want to work with other people. People want to pay you a lot of money to do so. I always yearn to learn, but I also yearn to teach. I was an instructor here. We're going to see my CV in a little bit, but I love teaching people things, but I love being the dumbest person in the room sometimes too. Not dumb as in I'm an idiot. Dumb as in I just don't know. I'm ignorant to these things. And I get an opportunity to learn. That doesn't put you at a disadvantage. That makes it, you see nothing but a ladder and you can climb it. You can get to the top and you can know things too, especially from a good teacher. So try to always be a learner or a student. Also try to be an educator when you can. Strive to become a better problem solver. You won't be a perfect problem solver. Like, it's just not going to happen. The problems are always going to be more complicated, but you're going to get more comfortable with solving them your way. There's no best way to solve a problem, no matter what, all of these certificates and courses and everything says. It's an organic sort of process, and you have to figure out how it works for you, right? This is some of that preachiness I was talking about. You want to evolve your communication skills. Communication is one of the most important things you could possibly do in life. You have poor communication, you'll fail at relationships, business and otherwise. If you have poor communication skills, you'll misrepresent yourself and what you need, what your desires are. And if you can't articulate things, people aren't going to know what you need from them. Those are incredibly important things. Be better at communicating. I think you should be passionate about work, or at least about the outcomes of your work, because if you're happy to do what you do, people are happy to work with you. They see that it's infectious, it's attractive, it's desirable. They want to be where you're at mentally. They want to be around you physically and professionally because you are a rocket ship taking them to the moon. It's happy times, it's good times, it's fun to be there. Some people are not going to be passionate about that work, and you don't necessarily have to either. Just understand, when you are less passionate about your work, a Debbie Downer, you're kind of negative. Generally, people don't want to work with those people unless they have to. Maybe you're the smartest person ever, and you're also incredibly cynical and pessimistic. And to get what they need to, where they need to go, they have to work with you. Fine, means to an end, but it's better if you can be passionate about it. Strong work ethic. This is in no specific order, but this was likely at the top for me. The best thing that you can do is have a strong work ethic. If you are lazy, people are going to see that. If you have strong work ethic and you can be realistic about something, man, this is dragging on. This is killing me. This is crushing me. 30-hour meetings, the triage work, all of the late nights. I'm salaried. It's not even like I'm getting overtime for this. You can be realistic about and have discrepancies about it. But if you have a strong work ethic and people understand that you're there to help them, you're there to get the job done, it's going to work out for you. I promise. Don't think that you are an island or a silo and you don't have support. You have adjacent support. You have to rely on that. It's a village. Use the people in your village to help you. I work on a team of 3 people. I'm one of them. I have 2 other coworkers. They are smarter than me in a ton of ways. They are stronger than me in a ton of ways. I rely on them for support every day in almost everything I do. And they rely on me. They can trust me whenever they need help, and I can trust them whenever I need help. Expand that out to that. That's that ring 0. That's your immediate family, your immediate work family, your career family. Professionally, go one more ring out. You got people all around you that are there to help you. As students, you got your coworkers, your fellow students, your colleagues, right, in this career that is college. And then you can go farther out. You've got TAs, you've got upperclassmen, you've got people in the lab, you've got people in the industry, you've got people that are educators that are teaching you, you've got people in other departments that maybe you've become friends because, hey, you were that math guy. That's the people you got to rely on. And then always know what you're about, right? Always feel good about doing well, but promote others. Promote others. Make sure other people get the kudos when they deserve. Whenever you see somebody do something, even if it's something small, and it has to be genuine, but even when it's something small, recognize them. Show them that you see what they did and that it's awesome. And thank you for your effort. That will always come back to you. All right, who am I? I'm Matt Gill. I told you that earlier. I'm a technology enthusiast. You can tell I also like to grandstand and preach a little bit, but I'm a technology enthusiast in no particular vein. I love PowerShell. That's sort of my love language lately, but I mean, that could easily change. I used to do a lot of .NET. I don't do a lot of .NET anymore, except PowerShell is based on .NET, so I guess I am kind of a liar too. Professionally, like Dr. Atchie said, I've been in this technology industries for 20 years. I started as a Marine. I got the sergeant. I was in the reserves. So I guess there's be an R at the end of that. I tried to be a .NET developer, and I found out not that great. Nah, I didn't really like it. Didn't like products. I think I didn't like writing off-the-shelf software. .NET's fine. C#'s fine. MVC as a design pattern's fine. Didn't particularly like what I was doing. Loved working for Mike and Barbara at JBM Technologies. They're in, I think they're still at the Small Business Development Center. Fantastic. If you have an internship opportunity, go there. I came over here as a sysadmin for a number of years and then swapped over to being a solutions team lead, the Office of Technology in Southeastern with Dr. Burst, currently the CIO, and Ray Dejan and everybody over there. And then while I was doing that, because it was convenient and easy and somehow you guys let me do it, I was an adjunct instructor for this department for about 7 years or 5 years or something like that. Well into COVID, and that was interesting, but then life got busy. I started having kids, work picked up, and I didn't do that anymore. I assume the offer's still on the table to come back. If you want a PowerShell course, I'm your guy. A Windows administration course, I should say. I swapped over to Blue Cross Blue Shield of Louisiana in 2019, right before something. I got a PlayStation 5 in 2020. No, it was COVID. It was COVID. And I became a sysadmin at Blue Cross, and that was really great. And then height of COVID, 2021, I was invited to become an SRE, a site reliability engineer, which I'll get to that in a minute. And I'm still employed. That's an important point, in spite of everything. Extracurricular-wise, for about 10 years, I ran the Experience Points radio show at 90.9 FM KSLU. EXPpoints.com is, I think, still accessible. And it's got hundreds of episodes of me saying really fun things about games that are very old. And then currently, as of this year, I'm the co-director of content for the PowerShell and DevOps Global Summit out of currently Bellevue, Washington, but we're going to probably move it to Florida in 2027. So everybody should go to, I think it's pshsummit.com or .org rather. PowerShell Summit will get you there. See what we got going on. A lot of cool stuff. Education, got a BS from here, got a MS from here, CS and ISAT respectively. And that was the end of that slide. I don't see the transitions on this side, so it's going to be a little jarring. This was my journey as a grad that I just made up. I started in high school over here. I'm breaking one of my rules. You never walk in front of your audience. High school was over here in 2005 because I'm old. And this is where I'm kind of at now. I also walk a lot. So I've been on an interesting journey, I think, because I fluctuated between two things: development focused and operations focused. Everyone's heard of DevOps, the wall, maybe you've heard about the wall. I shouldn't do my hand like that when I describe a wall. It says a different thing. There's this idea of the developer and operations wall, where operations is for stability and development is for innovation, and developers throw code over the wall, and operations people get hit on the head and they're upset by it. And then developers are like, why is my change not implemented? And operations people say, because I wanted stability and I can't afford to, destabilize the system. That's the DevOps wall. It's not really normal to kind of do this, but I've done it several times. I could not decide, in fact. I started and I went to the Marine Corps, and a lot of that is I was a tactical data network operator in the Marine Corps. I didn't say it earlier. That's mostly hardware related. And I say it's mostly operations related, but not fully operations related, because when you're in the Marine Corps, you don't really get to make decisions. You just have to follow standard operating procedure, because somebody allegedly smarter than you came up with an idea, and that's in the paper now, and now you're going to follow that. I joined Southeastern in computer science, and I started learning how to develop and program. Okay, cool. We're going more towards the development side now. And then I get a job as a .NET developer, no hardware whatsoever. And I just kept that. I plateaued at a full-on development sort of mode for a while and realized I didn't like development. Now I was wrong. I did like development. I love writing code. I write more code now every day than I've ever written in my life, personal projects aside, or personal projects included. But it wasn't that I didn't like the development. It's like I didn't like what I was developing. I didn't like going to meetings, and I didn't like discussing boilerplate software, and I didn't like the product aspect of it because I wasn't enthusiastic about that product, right? So I changed. I went full on the opposite way, and I went into the office technology at Southeastern, and I'm crawling on the floor of a data center under the drop of a raised floor, pulling cables, getting cuts and scars on my hands. And I'm dealing with Red Hat Linux, and I'm dealing with Active Directory, and I'm dealing with all of these operational sort of things. these things that produce the foundation and the concrete that all this all you developers write on top of this. And it was awesome. I loved that. And I stayed there for a while. But that's just one side of it. I went over to Blue Cross Blue Shield as sysadmin, and it was still mostly the same, but I wrote a little more code, got a little more interested in kind of bridging the gap a little bit more. And then whenever I became an SRE, a thing I did not know what it was, I got right back to kind of where I was in high school, except I have all this knowledge now. I'm right in between operations and development. I have so much invested in this operational knowledge and how I'm actually doing things and what systems I'm integrating with, and the sysadmin aspect of it, the configuration aspect of it. But every day I write new things too that are implemented, that are used, that are operationalized by those same systems that I'm a sysadmin and an administrator for. So it's really, really interesting to see that, okay, I didn't know what I was doing. I thought what I wanted to do in life was just build computers. Not like build the components, like literally just like, well, blue thing goes in the blue hole and, that's put together computers. I thought that's what college was about because we didn't have the internet, because it was the extreme dated past. But now, 20 years later, it's awesome because I get to choose what I want to do on a daily basis. I could be writing new code in whatever language is most appropriate, really. I could be dealing with configuring new systems as long as it drives the business forward and provides value. That's the important thing there. But I'm right in the middle, and it's the best place for me to be. And I think if you indulge me a little bit, it's kind of where SRE begins. In 2003, some people at Google said some stuff, and people took that real seriously, but not super serious until about 2016, when everybody really started to figure out what SRE was. Effectively, it's software development methodologies applied to operations. Remember that orange rectangle that I'm in the middle of right now? Software development methodologies apply to operations. It's crazy because everybody here, mostly developer, right? Developer focused, development and math, I think, right? It's generally computer science makeup. Whenever I talk about, that makes so much sense to me. Why would anyone do anything else? Well, just understand that when you're not writing something from scratch, you integrate things that are already written. And not everyone had the best ideas in the world. So you have to integrate things that maybe weren't meant to be used that way. You have to sometimes glue things together that materials that don't quite want to stick, right? So operations is dramatically different from an implementation standpoint. Operations is also completely different from software development in terms of like what the job roles are. It's a maintenance duty, right? Maybe it's observability, right? You've got alerting and monitoring that you need to deal with, because really it's there to support the development, the innovation from development. From an SRE standpoint, though, we look at reliability via a couple of things. Really, this should be the three things, and then risk management, but I didn't move the bullet over. Reliability via planning, automation, observability. We're going to talk about risk management a little bit later. The overall goal, summed up in just 2 words, is eliminate toil. Toil is a fun word. Toil it got a capital T, toil. I realize all these things that I've mistyped in here. Capital T, toil. What is that? We're going to talk about that in a second. And then where is SRE applied? Typically, in the big wide world of the industry and everything, you've got 2 ways of doing it. You either have centralized teams that do one thing for the entire enterprise, and there's some benefits to that. It also sucks too, because you have to compete for capacity and time. So then you can have people maybe associated with individual products or individual platforms or individual teams, where you might have a database administrator, a developer, a SRE-minded or operations-minded person, all on the same team supporting a product. And that's better, except they probably have less jurisdiction over big industry things, big things within the enterprise. Maybe there's another team they have to deal with in order to get anything implemented, to get things released. So there's pushes and pulls to that. The toil, manual work that provides no enduring value. It's the slog. It's the effort that you put forth to get to the fruit. It's the labor, but it's not labor that makes you stronger at the end. There's no love in toil. It is just calories spent. It doesn't make you stronger. It doesn't make you smarter. It makes you cynical. It makes you annoyed. It frustrates you. That's because we don't have everything automated out. We don't have all those problems solved. It's hard to do that. Toil for one person is annoying whenever it's very localized. But that same toil might not even be visible to the administration, to your boss, to your coworkers. If they don't deal with that platform, they don't deal with that system. They might not even see it. As an example, we did this. This is a real world example from Blue Cross. A developer wants to deprovision an old server. We're all virtual, right? So all of our VMs are provisioned via a series of magic steps. And then they run for a number of years. And hopefully within like a contract, we say, okay, well, we need to sunset this platform. We need to sunset this server. We're not going to update the OS anymore. We're going to just get rid of it. And the way that we used to do that was you'd go and you put in a request. It would get approved somehow, hopefully. And then you got like 20 manual tasks that get created in this orchestration system to remove it from all the platforms, to shut it down, make sure it has a backup, to do all these things that are necessary. Because it's not just delete the VM. We don't just do that. We're a highly regulated business. We got to keep things for a minimum of 30 days sometimes, maximum forever. We got to make sure that we've got a way to restore it if that approval wasn't, quite what it should have been. Maybe you should, I wanted to deny that. I clicked approve and then I didn't say anything for a month, but I need that server put back up. We've got a bunch of platforms like networking platforms, storage platforms, tons of security like 18 security platforms, guard. So many platforms. So these are all the manual tasks that go to all of these different teams. Some of them are even the correct team. And then we wait for all those tasks to be completed. And eventually, when they're completed, more tasks are created to remove the actual server from the hosting infrastructure. This is to get it off of Azure or AWS or vCenter or whatever. This is actually hitting the delete button on the virtual machine and on the on storage, cleaning it up. And then, hey, we're done. It's not so bad. That's what, six steps, 7 steps? If you had to guess, how long, y'all can't answer. You people, you definitely can't answer. How long, on average, would you think this would take? We have a virtual machine. We want to say sayonara to it. Request to completion. How long? Throw out numbers. It's fine. Don't think you're thinking like, if I was a VM, how long would it take me? How long? Think about it.
Like 3 months.
3 months? Oh man, you're really negative about that. Okay. All right. 3 months. We got 90 days. Anyone else?
2 months.
2 months. All right. 60 days. 2 months. All right. We're kind of in the middle here. 41 days on average. 41 days. That's from ticket creation, ticket open, or request open to request close. Now, that's not 41 days of effort. It's 41 calendar days from the start of a request, a desire, an articulated desire, to the completion, allegedly, because there's no technical thing that says this was really done. One of the problems with toil is consistency. 41 days passed on average. Let's explain how averages work. 41 is in the middle. That means some of them were longer. I happen to know one of these was like 180 days, at least. So averages are fun. They kind of lie a little bit. 41 days. Regarding toil, what could go wrong with all of these manual tasks, right? I gave you some of them, right? Everything. I hear you get Andreas who's everything. There are so many things that can go wrong. It's the lead time, I think, that really gets us, because these tasks go into queues, work queues, buckets, where people are looking every day and going, more work, please. Yes, I want to do some work. And they start doing whatever work that is. And okay, I'm done. That's not really how that goes. They ignore the queue because their kids are screaming, or they have to go to the bathroom, or they're out of coffee, or they're out of whatever else they're drinking. They're out of whatever. And they've got to get up and they got to walk around, or they're in a meeting, or they don't see it, or they don't want to do it, or it's just a Tuesday. There's so many reasons why people don't do this work when they first see it. Maybe somebody else will pick that up. I don't really know how to do that. John's the guy. He's the guy that's going to do this. Or just whatever reason. There's consistency problems. I think I know how to do that, and I'm eager. Let me do this. And then they don't have a knowledge base article to look at. They don't have the documentation to help understand what's actually going on. And they don't do the process the right way. Maybe the process is too monolithic, it's too big. There's not enough granular steps in it. So it gets left halfway done or partially finished, you know? Maybe somebody gets the request, there's a blocker for some reason, and then they go on PTO, they go to Disney World, and they are so about frozen, and they come back. They don't remember what they were doing at work. That was in the extreme past now. They've been to a magical land. Tons of things can go wrong with toil. So let's talk about reliability via planning. And I'm going to pick up the pace because I've got about 4,000 more slides. Reliability via planning it doesn't involve any code, generally. It doesn't involve picking up a keyboard at all. I don't know how 285 is approached now, project course wise, right? But whenever you are solving a problem, behind this magical screen, there's a whiteboard. And you should be able to solve every problem you have in your 285 project or 411 project or whatever project on this whiteboard without picking up a keyboard. You should be able to articulate and answer every question that you will have from project start to project finish. And if you can't, you probably shouldn't start coding yet, unless you forgot to start your project and now it's midterms and now you really need to do it, but the Battlefield 6 just came out. No. Assuming you didn't procrastinate. Planning is the most important step of anything. If you go off half-cocked, as it were, you're probably going to get to a find-out phase somewhere in the course of your journey, and that's going to be less desirable than just like kind of figuring it all out first, right? That's anything. That's investments, that's relationships, that's like buying a car, that's everything. Understand the problem, define the right solution. Part of planning for the process, reliability via planning, is transforming the processes that we have. This is a fatal flaw in a lot of people's problem-solving journey. Is they take something that already exists, some manual process, and I say, oh, I'm going to automate that. Well, you're going to have a pretty bad automated manual process then, because a lot of the same pitfalls that you're feeling now, just automating it might not solve that problem the best way. And if you're going to spend effort rather, spend it where it needs to go, right? Spend it in the best way. So we want to streamline our flows. We want to eliminate the unnecessary steps. All of that debt, right? Technical debt that you hear. There's planning debt. There's process debt too. Debt is just something you don't need, right? We want to eliminate that. Cut out the stuff that we don't need. Get it out of there. Clarify every component. Something about that first part that I forgot is by eliminating debt and by streamlining the flow, you are proving to yourself and everybody else in this process, planning sort of workflow, that you know what is going on. You are outlining a series of pieces, and you're going from start to finish. These are the things I need to do to make this a successful thing. If anyone has any problems with it, articulate that. That's the time to bring it up, because once you get to solving the problem with code or implementing the process or the plan, provided there's not like some extreme blocker, that's not a very slow process, because you plan it out. That's the thing that takes the time, the effort, the meetings, the meetings. You determine the risks. This is important too, because we live in a risk-related world. We have risks in everything we do. The goal for me is to minimize, hopefully eliminate, but it's always hard, especially with a lot of other teams, highly regulated industry, lots of money. Eliminate risk. You want to reduce risk as much as possible. Risks are risky, part of the word, right? Risks will cost you money, cost you time, cost you to rework things. You don't want to do that. You want to eliminate the reworkabilities. That means you want to shift left. You want to get as many people that are stakeholders and champions and whatever the fun word is in your industry that are going to get on board: legal, security, any of the hardware or infrastructure teams like networking or the server team or whatever. Anybody you need that's going to throw a wrench in this process, this planning process, get them on board as soon as possible, so they can throw the wrench now, you can plan around it, and later they can shut up. I mean, be on board. You want to collaborate with your major stakeholders, necessary partners, you're going to innovate and improve. Don't be scared to make things better. This is the time to do it. This is the audacity of the possible right here. Like, look at what we can do. and make a couple plans. You could say, oh yeah, this is what we can do. Plan 1, plan 2, plan 3. You want to document. This is the fundamental, one of them. I put an exclamation point here. That's because I wanted to make it big. But like Google Slides, it was really abrasive whenever I did that. We have a documenting problem in this industry, not at Blue Cross, not at Southeastern, in this industry. It's like we want to keep it a secret about what we're doing and how we're doing it. Some people are all about it. Some people are all about it. Everybody, I don't know if we should be about it as much as you, but we need to somehow meet in the middle. We need to get there. It needs to be just enough documentation to fully articulate what's going on and what could happen, what needs to happen. It needs to be standardized. It needs to be in a common place. We don't want to keep it a secret. We want people to know. It needs to be transparent. And we want to assign SLAs. What are SLAs, I hear you say? They're magic. Now it's more documentation, actually, but it's good. I had fun with this one because I got to do the AEIOU. So service level SLAs are service level agreements. These are sort of mechanisms SREs use to define effectively a contract of the expected outcomes. What is expected of a service or a product or an API or some component, right? This is a promise, sort of uptime, a promise of some delivered sort of functionality. It can encompass the scope, what's actually included in all this, metrics, how are we going to read these things, what's going to make up this agreement, responsibilities, who does what, remediation and monitoring and reporting. So how are we going to get this and maintain this? Penalties and remedies. So if something happens, who's on the chopping block? How are we going to fix this for you from a customer, customer provider standpoint? And a review revision schedule. That's important because sometimes people write a document and it's the best document ever. And then, 10 years pass and it's just a 10-year-old document that is very, very disconnected from reality at this point. So a review revision schedule is very important. Yearly is fine. Quarterly for things that really matter. SLOs, they're measurable targets. These are the things that we're trying to attain, right? And then SLIs, service level indicators. These are the actual data measurements related to that SLO. The SLO might be uptime. Okay, well, how are we going to manage uptime? Well, we're going to look at a counter for something. SLIs are the measured over the possible times 100. This is 100%. And then error budgets, that's the inverse of an SLI, right? That's SLI minus 100. That's your error budget. The reason we do this is we want to try to balance reliability versus agility, innovation and creativity versus hemorrhaging tons of money and not being able to do any more of that, right? When you get close to exhausting your error budget, stop pushing new code, stabilize the thing, triage, stop the bleeding, do whatever. An example of this would be something like Microsoft. This is totally a made-up example, so don't trust me. I don't even know if it's this good or this bad. I can't remember the actual agreements, but Azure guarantees. Did I spell guarantee right? I did. Azure guarantees 99.9, 3 nines. Wow, 3 nines percent of uptime a month. That includes virtual machines, networks, databases, SQL databases specifically, identity services like Entra, and storage. The metrics are going to have service uptime and proxy service checks. So it's not just up in the data center and you can't hit that. We have, checks around the world, making sure your website's up or whatever. Cool. And the responsibility, you're going to have the service leads, outage team, crash cart people, data center people, whatever. Those are the people that are going to be involved. We're going to use Azure Service Status Page to monitor that. That's going to be where it's going to be. We're going to review that for the quarterly. And hey, if we breach our SLA, we're going to credit you back some time, some money, 25 cents in a contract. It's going to be great. This is just a very super off the top of my head example. So let's talk about the toil. This is sort of the practical application of that deprovisioning scenario I mentioned. So we have reliability via planning. This is the toil with planning. The original process, multiple legacy platforms. We had platforms that were sort of called by that original process that we didn't use anymore. And people would just close and say, yeah, good. But each of those platforms potentially was holding up the overall flow, the overall process, right? So that's eliminating that tech debt. We want to take those out. The tasks sometimes were assigned to inappropriate teams, or which is even worse, I think, it was assigned to one team to then act like an operator and assign it to other teams that they think it's supposed to go to. Sometimes they got it right. Sometimes they had turnover and the people just didn't assign it the right way. Siloed knowledge slowed fulfillment. People didn't know how to do the job that they needed to do. So they didn't do it. They asked for a meeting. They asked for a sidebar, session to talk about it. And that slows down being able to solve that problem. Constraints funneled work and slowed fulfillment. Maybe only one person knew how to do it. So that was the guy that did all the work. But he can only do so much work at a time. He's got to eat lunch, So it slows that down. These were almost 100% manual, right? Only towards the end of this manual process was there actually automation. So that, of course, slows it down. No documented delivery expectations. Was 41 days too long? If you ask me, yes. But I mean, it was a default, I think 7 days, if I remember, but that's the default for everything. So nobody sees that anymore, expectation. There were limited published knowledge base articles, and the ones that were published, they weren't really kept up to date because that's hard. Documenting, admittedly, is hard. It was an unrefined request procedure. I want to say anyone in the enterprise could request any virtual machine in the enterprise could be decommissioned, which sounds like, giving everyone a loaded gun and saying, be cool. Because if you were my supervisor and I accidentally, put in a request to deprovision somebody else's VM, you could look at that kind of half-heartedly and go, that's fine, approve. Or your delegate, well, I'm on PTO, somebody will approve it, approve. I don't want to slow anything down. I guarantee you that was the one that took 1 day to deprovision. It was the most important VM in the entire enterprise, probably. There's no formal observability or metrics options. There's some kind of ways to look at it, but there's no formal one-stop shop, single pane of glass way to look at what's going on. Overall, we had low confidence in this because it was riddled with holes. It was, to quote a great man, brittle. And very long time worked. The refined process, it's longer, so you know it's better. Active and current platforms only, and they're maintained, right? We have a routine. I don't know if I say this, but we routinely go back and check. As soon as something is deprovisioned, or I'm sorry, as soon as a platform is decommissioned, taken out of service, it's removed from the process. We've made sure that it's very easy to do so, because if it's really difficult to do so, nobody's going to do it, and we're going to be right back where we were. We use platform jurisdiction guidance. That's a fun way of saying if you own the platform, by default, you're going to be the remediation team whenever something breaks. But turns out maybe you're not going to be the person. Maybe that's a special subset. You manage the platform, but you don't manage the process. That's fine. We can override that, so that's good. We made sure to publish flowcharts and documentation. I was going to steal the flowchart, but I wanted to stay employed, so I didn't do that. But it's a big one. It's a really big flowchart. We automated if possible, and that was the start. Automation. It's going to be automated. We know we're dealing with automation at this point. But if there's no way to automate it, we'll orchestrate it. We'll put that manual work where it needs to go, and we'll standardize the way that's created. We standardized all of the granular work components. We made this thing called resource tasks, which is a very abstract way of saying do a thing, on a thing, for a thing. That's it. Everything in the history of the earth can be summarized in do a thing, to a thing, on a thing. You don't have to know what it's doing or how it's doing it. You can just read that out. You can make a task and it'll just do it. Or it'll say, I can't automatically do that. And it'll make a manual version of it. It's fine. We recreated the request mechanisms. And we constrained it down. Only you should be able to request deprovisions for your servers. You shouldn't be able to request deprovisions for other people's servers. That doesn't make any sense. What business reason would you have to do that? Also, everything, no free text fields. That's another thing. Everything should be a reference. Everything should be an object. Everything should be either read-only and informational, or you are constrained by the orchestration platform and funneled exactly into a explicitly positive scenario, right? You have to assume as much success out the gate before the request is created. Because if it bombs out later, that sucks. That's dumb. That is not a great experience with the user. Let it bomb out immediately and tell them why something's not right. Click here to set a request up to get it right, or automatically fill out the request. We decrease the total time work, we increase the confidence, and then we plan using some type of project platform. We use Azure DevOps, but we've got epics, we've got features, we've got different types of tasks and user stories. We've got that work granularized out, and it's saved for all time or until we, get rid of Azure. You can go and look at exactly our process. It answers so many questions. Reliability via automation. Remember, we went through planning. That was reliability in the toilet. Reliability via automation. We want to craft sustainable solutions. We want to make things that are going to keep working. They need to be performance. They need to stand the test of time. They need to be a little flexible sometimes, but be very intentional about what they're doing. We don't want these one-shot, massive, monolithic solutions. We want to break things down. So, right tool for the right job. Who loves C#? Wow, really? No one. Who loves Java? That's unfortunate. Who loves PowerShell? There you go. Python. I could name languages all day long. All of these tools are the right tool for a job. They might not be the right tool for this job. And there might be reasons to not do a certain thing in a certain language. For instance, we developed these called the pillars, SRE pillars for automation. We are going to try to use the orchestration platform, core functionality of that orchestration platform. We use ServiceNow. We're going to use the core facilities that it has available to us out the gate. It's faster, it's tightly integrated, it's a first-party solution. We're already there. Why would we go anywhere else? Well, maybe it doesn't do what we need it to do. Okay, fine. We're going to use adjacent platform APIs. Everyone loves REST, allegedly, or GraphQL, fine. We're going to ask all these platforms that we're interfacing with via REST API. We're going to ask those questions and we're going to get those responses back, and that's going to be great. But nothing's free. And even this orchestration platform, as good as it is, every call takes away one of these calls out of a bundle of calls that we can make. We have to be very respectful. And we can't just make 4,000 calls just to ingest a bunch of data. So maybe we need to use external execution. We need to write, a binary and put it on an external server and call that one call, and then it goes and does its thing and it calls back in. Reduce 4,000 to 2. That's pretty good. Maybe it's easier to do that. Maybe there's already code that other teams have written that we can operationalize, and then later, we bring it up to a certain standard, and then we can operationalize that, and that's just easy. Big focus on reusability. The way I like to put this is micro and macro. Macro is the puzzle that you are trying to put together, they're trying to solve, and the micro is the puzzle pieces. We wrote a ton of puzzle pieces, probably 27 some odd puzzle pieces that are all interchangeable because they're all very, they're generic. They're specific. I mean, they are specifically for a thing to do a thing, but they're written in the same way. So we might have, 100 tiny little resource tasks, but they're all super simple. You know exactly what they do. It's not like there's one giant resource task that splits out into branching logic and goes all over the place. No, this is simple. It is where it is. It's maintainable, we have documentation, and we use source control for everything. Let's talk about resource tasks. This is also the only color in this presentation. A generalized task for automation, do a thing, for a thing, to a thing, or whatever. So an example, remove a resource for server 1 from Active Directory. Did you have a question? Okay. Take a snapshot for a server from our backup platform. Suspend alerting for a server from our alerting platform. Remove a resource. All of a sudden, look, we've got common operations that we're running that makes sense, right? Removing a resource, we're going to want to remove it from a ton of platforms because it's in a ton of platforms and we're trying to take it out. Create a resource, remove a resource. Again, this is following typical CRUD and also, I guess, PowerShell verbs, if you care. And then, on our hypervisor. So based off of this series of uniqueness, right? Remove resource on the hypervisor, we know how to send it over there. Remove resource in Active Directory, we know how to send it over there. It's a unique series of operation modifiers and platforms. And on top of that, we can also tell if this is a Windows server or a Linux server or any other type of thing. Maybe we don't, maybe it's a user. Remove resource for a user from, Active Directory, and then we have a payload for a group. And we know, hey, remove this user from this group. All of that can be separate, right? Separately executed, separate execution logic, very easily. So applying this automation to toil. Originally, yeah, it was really limited. Only towards the end of the original sort of V1, V2, V3 sort of go for the automation or for the process, was there any type of automation? And it was Ansible. And it was one guy on Linux, and it was siloed. I mean, you can go talk to him, I guess, but we'll see how that works. It was siloed. Refined automation, refined process, it was fully automated where we could. There were some security situations or some identity and access management scenarios where we could check something, but we couldn't change something, right? So we could determine if we needed to remove this particular server from a platform, but we couldn't actually remove it if we needed to. We would just cut a manual task for that. These are the things, the compromises we make. It could be fully automated. There's no technical reason why it can't, but there are bureaucratic and concerns about that, right? So we standardize the granular work, resource tasks, platforms, operation modifiers, the servers, the affected CI, different types of payloads that we can bidirectionally communicate with in the system. Scheduled date times. These can all be scheduled too. So if we needed to say, hey, push that out 7 days. We don't want to immediately kill this thing. We're going to put a wait. We can all do that. And we use Azure DevOps for source control as a result. So refined automation continued. The request is made and approved. This is sort of how it works. The request is made and approved. The requested item flow, which is the item that is spawned from the request. It controls creating the resource tasks and waiting on them to complete. We usually have 3 phases, right? The first phase is take a backup and suspend alerting. The second phase is turn it off and tag it as, in process of being deprovisioned. And then, what was it, phase? And then the third phase is kill it. Get rid of it, clean up. But we have some of those things that can run in parallel. Some of those things that have to take time. So we have to wait on certain things. And then also maybe we want to wait between phase 2 and phase 3, right? We want to give people a little bit of time to realize that, hey, things are moving very quickly. I think we need to pump the brakes in this relationship. We need to calm down here. About 20 or so resource tasks are created, and we allow parallel execution. How long do you think this takes? 41 days on average. How long do you think the new world takes to do this? No one wants to guess. An hour? Okay. What? 7 minutes. It could take less time if I didn't wait a minute or so every couple minutes to check an API response. 7 minutes. 41 days. Sorry for the people in the chat for this microphone. Just 7 minutes. Now, this is a fully automated scenario. That was 41 days of most of the work being manual, right? 7 minutes, all automated. We also, I didn't mention this earlier, but we standardize our remediation strategy because code is not flawless. Sometimes things break. Frequently things break. People change something and they don't tell you. The API goes down for maintenance and they don't tell you. They deprecate the API calls you were making and they don't tell you. So your code asks a question or it says to do a thing and it just can't, which sucks. We create a manual task. We have visibility from the SRE standpoint, right? We're able to say, hey, look, what happened? And we can get an incident for that. So we standardize that. And then reliability via observability, right? Proactive reliability. When you can see things, you can make data-driven decisions. It's super important, right? I know this might sound boring, but it makes you a ton of money. And it's really kind of cool whenever you can see all the bells and all the things flying back and forth. Metrics, logs, traces, all that other stuff. They offer deep insights into the behaviors of your platforms and the interconnected bits, the integrations that you have. Without it, it's all guesswork. You can detect anomalies early before impact. Impact is, hey, people can't log in. Before that, it's things are getting progressively slower. The disk is kind of filling up. The network's kind of slowing down. All of these things are detectable if you're looking for them. If you've got observability, You don't have to rely on a fire or someone screaming about it, usually in the middle of the night at 4 a.m. And it reduces mean time to detection and mean time to recovery. This is required to use SLI, or sorry, you require SLIs and SLOs to have this observability. You have to be able to measure it because you have to have the data. It's the foundation for defining and tracking the health of something, right? How healthy is this service? You know, if you have to put it on a progress bar, fine. If you have to make it a green, red, yellow sort of button, fine. It allows data-driven decisions. Dr. Edwards Deming, he's an educator and a statistician and everything, has a great quote. Without data, you're just another person with an opinion. So when anyone ever says anything, call BS on it sometimes, especially if you know that it is, and say, well, what data supports that? And they lose and you win. Now, you got to say it the right way. That's the important part of that. Don't be super smug because that might bite you. Communication skills, slide 2, right? But it's important to call people out on that. And then, yeah, scalable reliability only exists through automation and observability. Those feedback loops allow you to decide to keep developing, keep improving, slow down and stabilize, right? Because observability tells you if something's good, and automation makes it faster and makes it more consistent. And it's easy to change it and immediately see if something's doing better or not. You know, the feedback loop is, it's good or it's bad. Yes, sir.
So obviously the better automation improves the business, all the data is good for the business, good for the world as a whole. But as an engineer, say I am that one person who has a siloed knowledge, isn't it better for me to resist automation because, you know, it's job security, it's something only I can do. I'm not handing my job over to the AI.
You are the most unethical person I know.
Thank you.
Yeah, no, softball question, but yeah, that runs into an ethics issue where, you know, if you decide to hold the business hostage by effectively just sort of siloing and clutching your pearls and saying, no, I shall not, that's a trash person way to be. I'll say that. Now, some people are scared. Some people, learning's hard. I said learn and teach. Learning and continuing to learn and not forgetting how to learn is hard because it's a continuous effort, right? And people can get tired. I get that. You picked the wrong career. I am sorry. Technology does not stop. It does not slow down. AI is not going to take your job. It might take your job if you're not doing your job very well, and somebody else can use it to get better. I know Phil Jackson gave a great AI ethics and talk 2 weeks ago, 3 weeks ago, whatever. AI is not going to take your job. Not in my opinion. I think what it's going to do is it's going to, one, it might cause you to get laid off, but that's a business. I think your business might be making the businesses that do that might be making a bad decision. I think eventually they'll hire those people back or replace those people with more people, that replace the AI with more people. No one is going to beat you as a problem solver. And that's the thing you need to be. You need to be a good problem solver. So the siloed knowledge, every system that any industry has can be thrown away and another one can be stood up. And that other system could have new knowledge, new documentation, new any of that. So from a fear aspect, yeah, I see where people are coming from. I think ethically it's compromised. And then at the same time, no one wants to work with you. And maybe you can hold that hostage for a little bit. Maybe you can hold out until retirement if you're close to that, and you can say, I don't want to do it. Right? Like maybe you could play that game, but it is a game. Did that kind of answer your question?
Yeah.
Okay. Observability also helps with root cause analysis, RCA, postmortems, and blame games. I don't like blame games. Blame games suck because it's saying you did this. I keep pointing, I don't know, you're the guy. You did this. Sure, you did this. No, I was part of it. I participated, but it wasn't my desire to catch fire to the whole database. It happened as a result of me trying to do something good. Let's understand what actually happened. Let's understand how this occurred, right? Blame games are annoying. Blameless postmortems are a thing that we do where after something has occurred, an event, after the remediation and the triage work has happened, after the patient has been stabilized and the bleeding has stopped, everybody go get a nap or a drink. And let's come back and let's talk about what actually happened as professionals, as colleagues, as people that want to solve this and not have this happen again. If everybody is working on the same sheet of music and everybody's working with the idea that we're all here to help and do a good job and make the business grow and be better, there's no reason to be scared. You could be, I deleted an entire security database a month ago. Turns out if you send in a null or an empty value, some platforms decide just wipe it out. Whoops. Sorry, I didn't know. Now we know. They should have probably documented that in the API docs. They don't, they didn't. And this has happened before, and they still didn't document it. It's okay. It's okay to mess up. Mistakes are part of it. That's how you get better. You don't just you're not just awesome and awesome and awesome and awesome all the time. Like you're awesome and then you fail and then you learn and you get better. For the toil side of this, for observability, and I realize we're running out of time. This was disparate. We didn't have a lot of intentional metrics or intentional sort of reporting on these processes, on the big process, but even the small processes, how long did it take for this to happen? How long did it take for that to happen? You could sort of just in time build a report, run a report, but you had to want to do it, you had to know how to do it, and you really had to just work on it. People weren't really doing that. External platforms with limited access. We siloed off some of the information from people so they couldn't see it even if they wanted to. They had to ask somebody, and somebody had to copy and paste a screenshot that was on a different timeline. And then in the chat, you got 18 different screenshots, and somebody somewhere had to be like, all right, I think this is a correlation, which is just maddening. Or they had none at all. There was no observability. Man, now, wow, across the board, right? There's intentional dashboards from the outset about automated operations. Anything that SRE has built or run or contributed to, that's brought into the automation dashboard. We have green, blue, red indicators for every granular resource task. Red because it failed or was canceled. That's really it. Blue if it failed and kicked out a manual task. Green when it succeeds. And there's a lot of green, I promise you. We orchestrate everything via a platform dashboard. Through the orchestration platform dashboard, which has details, start and end times for every granular task and the overall processes, the automation failures and why they fail, incidents cut to SRE so that we have visibility on when they fail, why they fail, manual tasks cut to the remediation group so they can do the work, keep things going so it doesn't hold everything up, and then reporting on those slow completions. We actually have graphs of, okay, for deprovision of virtual machine, specifically remove resource from platform A. All the manual tasks that have been done for that are taking 17 hours on average. Maybe we should talk to the engineers on that team and figure out what we can do to help them. Why is it taking 17 hours? Why is it 17 business hours? We're not going to wake you up to do this. Or is it 17 hours in a day? That's a little more reasonable because if it happens at 5 p.m. and they get to it the next day, all right, that's about 17 hours. As soon as they log in, they do this one thing, it takes a second and we're done. External scripts generate logs for each run. We have PowerShell traces where appropriate. We've got logs of it telling us exactly what's going on. We know what's happening. Didn't start out like that. We had to refine that. We're good now. Additionally, we have a ton of data from a lot of other alerting and monitoring platforms coming in, so we can get that single pane of glass, right? We can start building that one-stop shop for all the data that we have, all the metrics, all of the metrics for the server CPU in this case. This is not really for deprovisioning, but if we were looking at some other things, we start to see, oh, there's problems, things are slowing down, things are whatever. We have to have observability, we have to have data, we have to have metrics for that. It used to be in a platform, well, it still is technically, in a platform that no one except 10 people can get into. Now, everyone that has access to the orchestration platform can search for any server and look at it and see, how is the disk looking? How is the network looking? You go into Linux and there's a million sensors for that. It's all in the same place, adjacent to the data, adjacent to their daily workflow, right? We can even do custom metrics, so it's extendable. And then all this ties back into risk management, right? Planning, right? Articulated desire and intent. We know what we're doing. We're not going to do something wacky in the middle of this. It's fully articulated, fully desired, fully written down. We know exactly what's going to happen, or what's intended to happen. At least we've solved all the problems, at least from a process standpoint. We might have to look something up, co-pilot something, consult with Oracle of documentation. We might need to do something to solve something with code, but we know what we're trying to solve with code. We just need to know how to write the code to solve that thing, right? Critical and important team collaborations early in the process. We make sure that we get the right people on at the earliest possible time. And then we have SLOs, SLIs, and error budgets to quantify those risks so that we know when to slow it down, when to stop, when to stabilize and hit our targets. We have to have targets to hit them, right? Automation, we have consistent execution. We know that if it's messing up, we can tweak it and it will start doing right. We have to be able to write that automation in a way that allows it to be, allows it to evolve. And then we reduce the human error aspect. You won't totally get it out of there because I'm writing the code. And I make mistakes all the time. It's how we learn. It's how we get better. But it helps a lot. And then observability. Those historical trends drive decision making. You're able to determine what your baseline is because you have a graph, you've got metrics, you've got traces, you've got logs. You can't make decisions without the data. A lot of platforms now are specializing in proactive monitoring, right? If you have enough data and baselining, you can predict based on what's happening now and what happened then. You can predict what might happen later. It's really, really cool. Thanks, AI or something. In conclusion, I know it sounded like a lot of you need to document. And I know everyone hates documenting. I got it. I hated it too. It's really important, super critical. I do this on a daily basis. This isn't all I do. I'm in meetings a lot. I'm setting up new platforms a lot. I'm not just doing SRE work, I'm doing other works too. It's like a platform engineer too. And so is everyone else on my team, right? We're consulting with the entire business. We're talking with Ladler, we're sort of an umbrella group. Because I said, I guess I didn't say it earlier, but we're a non-traditional sort of team. We're not under a manager, right? We're under the CTO. We talk to all of his directors and all of their teams, right? We consult with 20 or so teams in the business. Even on the development side, we're brought in to help solve problems that maybe they're not, they're very intelligent people, but they just don't know how to solve those problems with our skill set, right? So if this sounds cool to you, let's talk. Let's after capstone at Gnarly Barley, maybe, I don't know. I think that's homecoming for College of Science Technology, Gnarly Barley. Yeah. Thanks to the Computer Science Department and Southeastern for having me. I hope I made a good decision. I hope this was worth it. I hope there was some value to be taken from a student. I know from, thanks the audience, the direction for me. Thanks the audience. Thank you. I know it's hard sometimes being a student because you get all this development sort of layered on top of you. And then you also have to go to like biology and math and like theater and COM 211 and all of these, 2011, 2110, whatever the 4-digit number system is now. You have to do a lot of stuff to well around yourself and make this college degree worth it. I get that. Maybe you wanted something more technical. I could speak technically to you, but that's what you get already. You already get that. You get that every day almost. Having something a little more, I would say what's expected of you when you get into a job, when you get into the industry, even as a developer, a in the weeds, not forest for the trees developer, you are going to need to communicate with people. You're going to need to solve problems. That's the biggest strength of any of us in here is we're problem solvers, right? We can think logically through problems. So problem recognition is an art form of its own. Some people think symptoms are problems. They're wrong. You put Band-Aids on bruises. It doesn't make any sense. But problem solving is the single biggest thing. And I thought that maybe something a little softer than this will kind of help out. Where can you find me? I have a blog. Sometimes write on it, therealgill.com. MG at therealgill.com for email or mattg@powershell.org. I got a big boy address over there. You can show up at powershellsummit.org and check me out. And again, that's coming up in April 12th to the 16th, I think. There's an on-ramp scholarship. So look at that and write a paper and get that in there. If you at all are interested and read some of that, I'll be there, and I'll probably be at Gnarly Barley. I was saying in a few minutes because I thought I was going over there directly, but then GDoc was like, hey, you're coming to this capstone. So I guess I'm going to that capstone. We are 6 minutes over time, but are there any questions? I don't know if I can't see the chat, so if somebody has that pulled up. Are there any questions? I thoroughly enjoy speaking with you. Again, I'll be around. Just come up to me. I'm incredibly approachable, I think. Thanks. I'm going to clap on the chat. That's nice.
Oh, nice. Thank you so much. So thank you to everyone Again, capstone happening at 5 o'clock for midterm presentations. Gnarly Barley happening for alumni. And we will see you here hopefully next month for our third and final installment for DLS this semester. Have a great afternoon.